Good morning to you. Today we are discussing assignment. Assignment means we are distributing or we are segregating the work or our jobs to a particular machine or to a person. If n number of jobs are there and m number of workers are there, we are assigning each work to each person, or m number of machines are there and n number of workers are there, and we are distributing n number of machines. It means one machine to one person. We are just assigning or we are distributing the workload to a different particular concept. Here in assignment problem we are having the two concept. One is maximization problem, another one is minimization problem. In maximization problem we are concentrating on profit basis. In minimization we would like to reduce the cost of manufacturing the things. Based on these two concepts we here solve the assignment problems. The main condition in the assignment problem, the matrix should be n by n matrix. In case if the matrix is not n by n, by that time we should go for if it is not a square matrix, we should have to add dummy row or dummy column. Where is deficiency? Either it may be in the column wise or it may be in the row wise. Where the deficiency is there, no, by that condition we need to add dummy row or dummy columns. Here this is problem. Here there are n number of machines are there. It means m1, m2, m3, m4, 4 machines are there, and a1, a2, a3 and a4, there are 4 jobs. Here we need to assign one job to only one machine. We should have to work only one job on a one machine. Here one machine cannot run two jobs, or two jobs cannot be assigned to a single machine. Only one machine can assign with only one job. Based on that concept we are solving the problem. The whatever the matrix it is containing, that matrix is a cost of a unit. One cost, while producing one unit, what is the cost for a job A, job B, job A, job B, job C and job D. With respect to machine 1 it is 14 rupees, machine 2 it is 21, machine 3 it is 14 and machine 4 it is 6 rupees. Likewise B jobs, C jobs and D jobs. Here before solving the problem we should have to think whether the matrix is a n by n matrix. It is a square matrix. Anyhow, four number of machines are there and 4 number of jobs are there. For that reason it is having the n by n matrix. There is no question of adding the dummy row and dummy columns. Anyhow, it is a square matrix, n by n matrix. Now how to solve this one? Here we need to consider, first we should go for row minimization. Row minimization in the means, in first row, in machine, in one row, which is the least element with respect to second row, which is the least element. We should have to identify them. In machine 1, B is the least element, and machine 2, 18 is the least element, and machine 3, 12 is the least element, and in machine 4, 3 is the least element. Just by considering the least value, we should have to subtract other remaining elements in the minimum value. Now 12 minus 14 is 2, and 15 minus 12 is 3, and again 15 minus 12 is 3. Now we are writing 2033, and then come to the second one. Here minimum value is 18. Again 18 minus 21 is 3, and 18 minus 18 is 0, and again 18 minus 18 is 0, and 18 minus 22 is 4. We are writing the second row 3004. And then come to the third one. Minimum value is 12. 12 minus 14 is 2. 17 minus 12 is 5, and 14 minus 12 is again 2. We are writing here 3, 5, 0 2 sorry 2 5 0 2, respectively. Fourth column, sorry, fourth row, 3 2 0 3, 3 2 0 3. Now this is row reduction. Then we are moving towards column reduction. Again, whichever the smallest value in the second step, which is the least value, if it is not a zero number, if it is if there is no any zero values, then select the minimum number and subtract remaining elements with the minimum number. Here 2 is the least value in this one, and 2 minus 2 is 0, 2 minus 3 is 1, and 3 minus 2 is 2 minus 2 is again 0, and 3 minus 2 is 1. Here 0 1 0 1, we are writing here 0 1 0 1. And then similarly in the second B column we have 0 is the minimum value, then there is no changes in the column, rewrite the column B. Similarly, in come to the C column, here also we are having the 0 element, then there is no necessary to make any changes. Then come to the fourth column, here we are having the value 2 is the minimum value, and again subtract the remaining element by 2. 3 minus 2 is 1, 4 minus 2 is 2, and 2 minus 2 is 0, and 3 minus 2 is 1. 1 2 0 1, 1 2 0 1. After this one, after completion of row reduction and column reduction, we should have to cross verify if any row or column, whether is there any non-zero elements. Anyhow, in first row you are having the 0 element, second row, third row, and fourth row. Again in column in row wise also we are not having any non-zero numbers. This is this row 1 is having 0, row 2 is having 0, row 3 is having 0, and row 4 is also having 0. Now we should have to assign. Before assignment, we should have to strike out the maximum zeros. Maximum zeros we are going to reduction orders. There are reducing orders. Here it is having 3 zeros. First reduce it, this one, and then come to the first column, sorry, first row. This is also having 2 0, and this is also having 2 0. Anyhow, you can strike out any one, this one and this one, and then come to the last one. It is also having 0, then strike out this one. By striking either vertical or horizontal lines, by addition of these two, horizontal as well as vertical, you should get n by n matrix, or n is equal to whatever the number is there, no, that number, that horizontal number or horizontal plus vertical numbers it should contain. Here n is equal to 4, strike lines are all are horizontal lines, okay, n that horizontal strike line is also 4. Now our condition is satisfied. Before going for assignment, we should have to rewrite the same equation. This is 0 0 3 1 and 1 0 0 2 and 0 5 0 0 1 2 0 1. Here before assignment we should have to think that, or we should have to cross verify which row or which row is having the only 1 0. First we should have to assign for that row. In first row it is having 2 zeros, and the second row it is having 2 zeros, and the third row it is having 3 zeros, and fourth row it is having only 1 0. First assign the fourth one. Then whatever the vertical zeros are there, vertical in column, whatever the zeros are there, no, you need to strike out. Because why? Because you already assigning C job to the fourth machine. It means C job is already allocated. We should not go for second assignment for with the same C job, because C job is already allocated. Then go for first row. Again it is having 2 zeros, leave off, and come to the second row. It is having only 1 0, and we need to assign this job 2 for machine 2. Job 2 is also sold out. With respect to that, we should have to strike out the upper 0 which is in the B column, because B job is already allocated for machine 2. Then again we should go for first row. Again it is having the 1 0, and we should have to strike out machine 1 is allocated to M1, and then only left is third machine we need to assign, because it is left with only 1 0. Now finally we need to assign, or we need to think of assignment machine and jobs and duration. Here M1 is allocated to A, and M2 is allocated to B, and M3 is allocated to D, and M4 is allocated to C. Okay, then duration is, again we need to calculate it not from this matrix, we should have to go for original matrix. M1 is allocated to 1, it is duration is 14, and the machine 2 is allocated to B, and the duration is 18 hours, and machine machine 3 is allocated to D, that is 14 hour, and machine 4 is allocated to C, that is 3 hours. Okay, total duration 19 1 2 3 4 49 hours. Total work consumption from the all machines and from the all jobs, it is 49 hours, and this is the least time to manufacture all the jobs. Thank you.